Today I am going to show you one of our most interactive embedded builds, the magnetic switching gamepad powered by STM32F405. The gamepad uses 16 Hall sensors routed through two ADC analog multiplexers which are connected to ADC channels on the STM32F405. We are using DMA for high-speed sensor data acquisition. Actually, it's super fast. Each ADC channel is dedicated to one multiplexer, allowing us to scan all 16 inputs in parallel using a single timer-driven loop. The boosts sampling speed significantly, ideal for real-time responsiveness. The OLED display features a built-in menu systems. Obviously, we have coded the menu system. Using the encoder, we can scroll through settings like calibration, sensitivity, and adjustment, and even live debugging options, all embedded in firmware. All processed sensor data is streamed through UART to a custom Python interface. This makes it super easy to visualize real-time input actively. This is the Python graphical interface. It reads data from the STM32 and displays real-time values for all 16 Hall sensors. You can instantly see how magnetic field shifts as I move my hand, or a magnet across the sensor area. Everything you see, sensor logic, encoder logic, OLED menu, and UART stream, and also the graphical user interface is completely built from scratch using STM32 Hall and Python. Obviously, this platform is scalable, efficient, and open for future expansion, including USB HID or Bluetooth support in future versions. With modular firmware and clean signal flow, this magnetic gamepad project can be the best for advanced input systems like BMS, robotics, or magnetic gesture interface. If you like this build, drop a like, subscribe, and comment below. Let me know if you want a tutorial or you would like to see this gamepad evolve into a full HID device. Until the next time, keep building right here on Creative Factory.